I am here to discuss a small topic, that is tension in a string or rope. So let's start with a small problem. Suppose there are two students, student S1 and student S2, pulling a rope at opposite ends with a force of 100 Newton each. So here the question is, if the tension T develops inside the string, what is the value of T, or what is the tension in the rope? What is the tension in the rope? Some students immediately say it's 200 Newton, some says it's 100 Newton, some say something else, etc. etc. So before understanding or before finding what the value of T actually is, let's understand tension hoti kya hai. Let's understand what tension actually means in the string. So tension. So let's understand through a small simple definition. It is a force developed inside the string. It is a force developed inside the string or rope axially. Important point, axially, when the string is stretched or taut. When the string is stretched or taut. तो टेंशन एक रोप में या स्ट्रिंग में तभी डेवलप होगी जब उस स्ट्रिंग या रोप को खींचोगे, यानी स्ट्रेच करोगे. Now let's understand this with a simple example. If I have a rope simply lying on the ground, there is no tension in the rope. The tension is 0 newtons because it is not stretched or taut. Now if you say I have another rope lying like this, again the tension here is 0. Doesn't matter how it is lying. Let's say another example. If I have a stretched string tied with a box of mass m, so now the mass m has a downward force or downward weight mg, and now this will have a tension T developed in the string. Now another main point, that is tension always develops in opposite direction of object and towards the center of mass of a string. That is the main important part. Now let's see what will be the value of T tension in the example taken here. This one. Here you see the mass m is stationary, or you say the acceleration of the mass am is 0. So we can use here Newton's second law. So using second laws of motion equation, we say F net is equal to F net at mass m is equal to mass into acceleration. So here T minus mg is equal to m into 0, which implies that T is equal to mg. Right? Now let's move back to our problem. That was two students pulling the rope with a force of 100 Newton each. Now for student S1 and for student S2, we will solve for student S1, then you will understand it from the point of view of student S2 as well. So here the tension T develops in this direction, and student S1 pulling with a force of 100 Newton. So at student S1, we have acceleration is equal to 0. So 100 minus T is equal to, let's suppose mass of the student is m1, so m1 into acceleration is 0. So here 100 is equal to T. The tension in the string is 100 newtons. Similarly, at student S2, suppose its mass is m2 and acceleration, again it has 0 acceleration. So 100 Newton minus T is equal to m2 into 0. So here again T is 100 Newtons. So the tension developed in the string was 100 Newton. Alright. Thank you.